name is Anya and I handle business development at Kmine. Before we get started, a quick reminder to follow our LinkedIn page for the latest news and upcoming webinars. And also thank you everyone for being here. Your support is really appreciated. So today's webinar will delve into Antarctica and the future of operations there. I'm excited to announce that we'll be joined by a special guest, Dr. Julien Cornet. He's a geoscientist and polar guide, and he will share his first-hand experiences of Antarctica and discuss human impact on this unique environment. Additionally, don't miss out our upcoming podcast with Julien. We'll explore a wider discussion on the challenges scientists face in Antarctica and what the future holds for this icy continent. So first, let me introduce you to Kmine. We started in 1994 in Ukraine and have since expanded our operations across Europe, United States, and Canada. Our team is composed of a varied group of developers, geologists, and mining engineers, including specialists certified in NI 43-101 and JORC reporting standards. We cater to clients ranging from small exploration to major corporations, with our emphasis always on providing high quality but cost-effective solutions. At our core, we focus on our software tailored for the mining industry to assist at every phase of a mining project, from initial exploration to full-scale production. This software includes 12 adaptable models that are suitable for both open pit and underground mining. What makes our software unique is its flexibility. Whether you manage a small operation or large corporation, you can select the models that best align with your operational needs, and it can be one model or 12. These models address all aspects from geological data processing and surveying to developing optimized mining plans for both immediate and future projects. With the ability to integrate IoT devices and dispatch systems, our software supports also real-time monitoring, allowing for swift and informed decision-making. But our product was developed from genuine industry experiences. It's crafted to tackle challenges we faced in our consultancy roles. As I mentioned before, our team includes qualified persons who produce reports compliant with NI 43-101, SK 1300, and JORC standards that are customized for various project phases, for example, for feasibility study, mineral resource estimation, or preliminary economic assessment, or definite feasibility study. Our expertise covers a broad spectrum of hard rock commodities, including critical minerals. And if you're interested in learning more about our services and how we can assist your project, you can leave a comment below or contact us via our website contact form. So today we'll concentrate on issues vital to humanity concerning Antarctica. We'll explore how research conducted to Antarctica can inform climate modeling for both the near future and over a million of years. We'll also discuss how mineral resources are evaluated, who might have claims to them, and we'll delve into aspects of environmental protection alongside with intricacies of international policies. And that's where our speaker, Dr. Julien Cornet, will give us his insights. So Antarctica, which is the 7th continent, it's unique as the world's only uninhabited and least developed landmass that doesn't belong to any nation. It's larger than both Australia and Europe combined. It's roughly 2.5 size of the United States. And including its surrounding waters, Antarctica covers only 10% of Earth's surface, but it holds over 80% of the planet's fresh water reserves. The other thing that is interesting about Antarctica is that it's actually the highest continent on Earth. There is this massive mountain range, the Transantarctic Mountains, that splits it into West and East Antarctica. And also Antarctica is the driest place on the planet. You'd think that with all this ice, it would be wet, but nope. Only 50 millimeters of precipitation falls on the polar plateau each year, and it's less than in the deserts. In the McMurdo dry valleys, which are these unique ice-free spots, there hasn't been any rain or snow for like 2 million years. So summer in Antarctica begins in late October. There are, of course, no polar bears. They are in Antarctic, and penguins outnumber humans significantly. Antarctica also once had like nuclear power plant, but it doesn't work anymore, and it still maintains a fire department for safety. It's also only a continent without time zone, making timekeeping somewhat unique here. And the lowest temperature ever recorded on the continent was in 2010, reaching a chilling minus 93.2 degrees Celsius or minus 135.8 degrees Fahrenheit. That's really cold. It's also one of the few islands that haven't been colonized by ants or reptiles or snakes. So you might find it surprising, but actually palm trees once thrived on what we know now is the continent of Antarctica. Researchers from the Joint Program for the Study of the World Ocean have delved deep into Eocene period, literally reaching the bottom of this epoch. By drilling through 1 kilometer of sedimentary rock, they retrieved samples containing pollen from palm trees as well as from plants akin to today's baobab or macadamia. Recently, scientists have shown a keen interest in early Eocene due to its potential as an analog for global warming trends. This interest stems from the desire to predict what might happen to our planet in the coming 10, 20, or even more years by drawing parallels between the Eocene climate conditions and those we're experiencing now. In 2020, evidence of the ancient rainforest from about 90 million years ago was found in a sediment core near Pine Island Glacier, containing pollen, spores, and plant remains, suggesting a much warmer Antarctica in the past, and it altered our understanding of its climate history. So today, over 30 researchers from various international institutions are engaged in ice core drilling campaigns in Antarctica. They focused on understanding the dynamics of the ice sheet and the carbon cycle within the Southern Ocean. Also, the historical patterns of the Earth's climate. Today, the Rift Tip project of the Brunt Ice Shelf is specifically examining the mechanism behind crack propagation, which is crucial for studying iceberg calving. During the 2025 season, fieldwork in Antarctica will include the deployment of fiber optic seismic sensing to gather high-resolution fracture data, and teams will also drill ice cores to investigate how stress concentrations, ice crystal structure, and toughness interrelate. One significant project named Rewind centers on the Southern Ocean, a key player in the global carbon cycling. This ocean currently absorbs over 40% of human-induced CO2, but its future role as either carbon sink or source is not yet clear. Researchers intend to drill a deep ice core near the Bass Sky Blue depot on the Antarctic Peninsula, and the aim is to analyze sediments that hold annual resolution records of CO2, marine diatoms, and chemical markers dating back to the Holocene epoch, which is 11,000 years ago. And it helps to understand how Western winds and sea ice have historically influenced CO2 interactions with the atmosphere. Moreover, numerous other initiatives are underway focusing on topics like ice sheet collapses, subglacial lakes, the evolution of glacial interglacial cycles, and faunal migrations. These studies will provide crucial data for modeling future climate scenarios, aiding in global climate change mitigation strategies. The overarching question in Earth science regarding the causes of glaciation and, by extension, climate change remains open, with over 100 hypotheses attempting to provide answers. Glaciation theories are broadly characterized in two groups: those attributing ice ages to extraterrestrial influences and those suggesting terrestrial causes. The extraterrestrial hypothesis includes unprovable scenarios like cloud of cosmic dust, comet tails blocking solar radiation, which in current science remain speculative. One of the wonders, actually, of Antarctica is the Wilkes Land crater, potentially one of the Earth's largest impact crater at about 480 kilometers wide. It lies under the East Antarctic ice sheet. It was detected by NASA GRACE satellites through gravity anomalies, and it's estimated to be about 250 million years old. It might relate to the Permian-Triassic extinction event. Its status as an impact crater remains debated due to the challenges of studies beneath the ice, but if confirmed, it could provide significant insights into Earth's geological and biological history. Among terrestrial hypotheses, one might consider volcanic dust clouds obscuring sunlight, but this explanation also lacks solid backing. An intriguing terrestrial theory posits that living organisms might drive ice ages. During warm ice-free periods, rapid plant growth could deplete atmospheric carbon dioxide, which acts like glass in the greenhouse, trapping heat. Reduced CO2 levels could lead to cooling and glacier formation. These glaciers then destroy vegetation and depress the Earth crust, spurring volcanic activity that releases CO2, initiating a warming cycle. However, calculations indicate that even a 90% reduction in atmospheric CO2 would only lower temperatures by about 3 degrees. This is very minor comparing to the ocean capacity to absorb and release CO2, which is 50 to 100 times greater than that of terrestrial vegetation. Thus, most of the theories, both extraterrestrial and terrestrial, fails to hold up under scrutiny. Recently, however, new evidence have surfaced providing the basis for novel hypotheses explaining the origins of the Earth's glaciations. Tealites, which is compacted clays hardened by the weight of overlying layers containing striated boulders of various sizes, provide evidence of past glaciations. These geological formations have been discovered in diverse locations such as Canada, China, Brazil, the Sahara, South Africa, Siberia, and Antarctica. The varying ages of tealites suggest multiple glaciation episodes throughout Earth's history. It's implausible that glaciation would occur in regions like the Sahara or Brazil when they were situated in the tropics or subtropics, as this would imply a scenario where the entire Earth was covered in ice. Such total glaciation would represent a stable state for the planet. However, geological evidence shows that the liquid water essential for the emergence of life around 3 billion years ago was present on Earth at least from 3 to 4 billion years ago. So it seems that the continents currently located in the tropics were once positioned near poles, moving across the Earth's surface much like ice flows on water buoyed by the liquid subglacial material. This line of reasoning led the renowned geophysicist and Greenland ice cap researcher Alfred Wegener to develop the theory of continental drift. Geophysical and paleontological evidence shows that past glaciations occurred when continents moved to polar regions. Around 600 million years ago, Gondwana, including Africa, South America, Antarctica, Australia, and India, was near the South Pole during the Precambrian glaciation. It later merged with Laurasia to form Pangaea. Pangaea's breakup around 130 million years ago led to significant changes. By 70 million years ago, Antarctica and Australia were at the South Pole, surrounded by warm currents. The opening of the Drake Passage about 20 to 22 million years ago isolated Antarctica with a circular current, leading to the formation of its ice sheet and global cooling. This cooling influenced the Northern Hemisphere glaciers and Greenland glaciation 10 million years ago. Human evolution and current climate are tied to these geological shifts involving land, ocean, atmosphere, Antarctica, and human activity. So Antarctica is very rich in mineral deposits, and one striking example is the phenomenon known as blood falls. Here, water from under the Taylor Glacier, which is laden with iron from the bedrock below, interacts with air, and when this happens, the iron oxidizes, giving the water the vivid red hue that looks like blood stains on the ice. The major challenge when we talk about mineral deposits in Antarctica and assessing them is the extensive coverage of dynamic ice streams and glaciers. The vast majority of the continent is shrouded in snow and ice, often reaching depths of hundreds or even thousands of meters. This creates two problems. First, exploration with boreholes at such depths, and second, mining from such depths. Moreover, the skepticism about drawing parallels between Antarctic mineral deposits and those on other continents, since the rocks have been encased in this ice for millions of years, they haven't undergone the same weathering processes that typically occurs elsewhere, potentially altering their characteristics. For example, coal deposits have been identified in two Antarctic regions, the Transantarctic Mountains and the Prince Charles Mountains. One of the signatory countries to the Antarctic Treaty engaged a mining consultant to evaluate economic feasibility of coal extraction in the Transantarctic Mountains, and after a short expedition to the site, the assessment concluded that the venture was not economically viable. Better coal reserves exist elsewhere on Earth, and this remains undeveloped. The northern part of Antarctic Peninsula shows promise for porphyry copper deposits recognized as a part of the Andean metallogenic province, and the South Shetland Islands and Antarctic Peninsula host a variety of minerals, including volcanic iron, porphyry deposits of copper, molybdenum, and iron, as well as polymetallic deposits containing copper, lead, zinc, and silver. In the northern Prince Charles Mountains, kimberlite samples at Mount Meredith indicate a potential for diamonds. The Dorn gold deposit in the northern Victoria land stands out as the first major gold mineralization identified on the continent, and highlighting these areas as a prime for mineral exploration. Iron ore is also abundant in Antarctica's surface and sub-ice rocks, but its isolation and low grade renders it economically unviable for mining. The Dafik Massif in East Antarctica is considered the theoretical source of chromium. Antarctica holds a lot of secrets. Besides the crater I mentioned earlier and discovered rainforest, another anomaly worth to mention is the Singing Glacier of Antarctica, specifically the Ross Ice Shelf. It produces low-frequency hums or vibrations when wind blows over its surface, creating and interacting with snow dunes. These sounds, inaudible to humans, offer insights into shelf stability and are part of ongoing research into how climate change affects Antarctica ice structures. Geological exploration in Antarctica uncovers new findings really yearly. Moving to recent discoveries, 2 years ago, scientists from the University of Texas in Austin discovered a city-sized subglacial lake, Lake Snow Eagle, under 2 miles of ice in East Antarctica's Princess Elizabeth Land. This lake, stretching 30 miles long, 9 miles wide, and 650 feet deep, with sediments up to 1,000 feet thick, could hold clues about past climate conditions and ice sheet behavior. Also, in the same year, a new ecosystem was found, the Ross Ice Shelf in the underground river system. New Zealand researchers, using a hot water drill, discovered hundreds of shrimp-like amphipods living 1,640 feet below the ice, shedding light on life on extreme conditions and offering implications for life on either icy worlds. This year, Russian geologists reported finding a massive oil reserves in Antarctica, estimated about 511 billion barrels, which would be about 10 times the North Sea's 50-year output. However, skepticism surrounds the feasibility and legality of extraction due to the treaty's environmental concerns, and the Adam Smith Institute, for example, notes that these are just preliminary findings and not necessary reserves since extraction is banned. So, to clarify, mining in Antarctica is completely off the table for now. The Antarctic Treaty, which was signed back in December 1959 and went into effect in June 1961, makes sure of that. And no country has sovereignty over Antarctica. It's all about scientific research there. And now, before this treaty was placed, a few countries did take stake claims on various parts of the continent. For example, Argentina got Argentine Antarctica, but this overlaps with claims by Chile and the UK. Australia claims the Australian Antarctic territory, which is the largest area to claim. Chile also has the Chilean Antarctic territory overlapping with both Argentina and British claims. France claims Adelie land, and New Zealand controls the Ross dependency. Norway has Queen Maud land and Peter First Island. And the UK has the British Antarctic territory, which again overlaps with Argentina and Chile claims. These claims were all made before the treaty came into effect, and the treaty doesn't recognize or dispute them, but essentially freezes them where they stand, which means no new claims can be made, no existing ones can be expanded while the treaty is still active. The Antarctic Treaty, effective from June 23rd, 1961, allows any UN member to join with 52 signatories currently, 28 of which are constitutive parties due to significant research. This treaty has successfully navigated territorial and disarmament issues, maintaining strong commitment from its members. The broader Antarctic Treaty System includes various agreements, organizations, decisions from consultative meetings, covering everything from scientific research to environmental and safety regulations. The Antarctic Treaty has some fascinating provisions that really shape how we interact with this unique continent. First off, it's all about peaceful use. No military bases, maneuvers, or weapons testing are allowed. It's a place dedicated to science where research must continue freely, just like it did during the International Geophysical Year, promoting international collaboration. When it comes to sovereignty, the treaty essentially puts a freeze on all territorial claims, as I said before. Can't make new ones or expand existing ones. There is also a strict no-go on nuclear activities, no detonation of nuclear explosives or disposal of radioactive waste. To make sure everyone's playing by these rules, any country that signed the treaty can send observers to check out ships, stations, and equipment down there. Countries are also required to give a heads up about their expeditions, and there are regular meetings where everyone discusses how to move forward with the treaty objectives. Lastly, there is a built-in system for resolving disputes and even modifying the treaty if needed, which keeps the agreement adaptable over time. This treaty successfully maintained Antarctica as a zone of peace and scientific discovery, free from the geopolitical strife that affects other parts of the world. So the issue of mineral exploitation in Antarctica was first discussed in the 70s within the Antarctic Treaty System, leading to a voluntarily moratorium in 1976 and adoption of CRAMRA in 88. Environmental opposition, particularly from Greenpeace and the WWF, culminated in Australia and France refusing to sign CRAMRA, leading to its failure. The controversy paved the way for 91 Protocol of Environmental Protection, showcasing the influence of environmental advocacy and the challenges to the treaty consensus. The Antarctic Treaty recognizes tourism, which began in the late 60s and grew significantly in the late 80s. Tourists can enjoy various activities like walking along the rugged coastline with icy mountains as a backdrop. However, they must adhere to strict environmental guidelines to protect the region. And now joining us is Dr. Julien Cornet. He's a scientist who has served as a polar guide for 3 years. He will share his insights of his experience with Antarctic expeditions, both as a guide and as a scientist. So Julien, it's great to see you.
Yeah, thank you, Anya. Great to see you too. Happy to be here, and thank you for the invite. I'm really happy to join this webinar.
What are the primary challenges for researchers when they are actually in the field in Antarctica? What do they face besides extreme temperatures, I guess?
So you mean when they are on the field?
Yeah. Mm-hmm.
Yeah. well, the type of science I've done in Antarctica was mostly water-based out of an expedition ship. So and the challenge is it always comes to resources, the resources that are available down there in Antarctica. So you can only bring what you can bring, or you can only use what is available to use, because there is no, like, as you know, there is not much coming in from the developed side of the world. So you have to do with what you have, and sometimes it's very challenging because as a scientist you need time. That time is a big thing, and sometimes you don't have the time, but sometimes you need to ally time with other type of resources such as boats or zodiacs. And
so you mean there is no enough resources? There's not enough resource to actually camp on the side for and give time for scientists to do their work. That's what you mean by resources?
Yes. So, like, for my part, the experiences are all different. My part was that I had to lead a science project, a science program. Sorry. But I wasn't given the resources in terms of time and in terms of logistics to do the work. And it was very challenging to be a scientist on this ship. So that's why I've decided to change. But like, this was my own experience. Because you can either do like this, or you can be a scientist coming from a university with a specific research project to go to Antarctica, and there you will be going either in the Rothera station, which is the British Antarctic Survey station in the peninsula, or if you need to do science in the Ross Sea, then you go to the US station. And I have a gap in my mind. I forgot the name. Like the most McMurdo. Here you go, McMurdo station, and so on and so forth. So, and in those research stations, that's definitely something you have to be careful with, is the resources that are available in those research stations. Well, McMurdo is now becoming a huge hub, but the Rothera station is still rather small. And if you take the French one, Durmont-d'Urville, is also a rather small station, and you have only such a specific amount of time, specific amount of resources, and a specific amount of money you can spend, because money is brought by the scientist from your funding. So those are the limiting factors for doing science in Antarctica.
How does it work logistically? Like, obviously you won't have like in terms of the food, in terms of I understand that when you bring the camp, you kind of like bring all of the stuff you need with you, but in terms of the food, how does it work with Antarctica? Obviously there is no like Burger King around. So like, how does it work in terms of even cooking, grocery deliveries, how does it work?
Well, I haven't been to McMurdo station, but I have heard from a source that I trust that they have a Burger King or a Pizza Hut or something.
Really?
I'm not 100% sure, but I've heard of this story. Anyways, but yeah, in terms of food, everything is brought with planes in between seasons, so there's no grocery stores, no streets, no street names, nothing like that. It's everything coming from with the ships. So so if you take the Rothera station, for example, it belongs to the United Kingdom, so it comes with the military ships from the United Kingdom, and everything, they come there twice or three times, once a year. They come once a year to refurbish the station. It's all about canned food and and or dried food, processed food.
In terms of even human actions that are impacting Antarctica right now, what do you see there, and how do is there any patterns you see in Antarctica in terms of like climate change that maybe like a few years ago you didn't see? How does it impact Antarctica?
So the human impact or the on Antarctica, it's something that you can observe. Yes, depending on where we go in Antarctica. So I've spent a lot of time in a peninsula, and the peninsula. So if people don't know what the geography of the Antarctic, the peninsula is the one that is coming up and saying hello to the southern tip of Argentina and Chile. So in that place is known to be one of the place in Antarctica that is warming up the fastest. So there you see a lot of ice disappearing. So what used to be covered before are becoming uncovered. So nunataks, for example, nunataks are mountains that used to be under ice and just tipping out a little bit.
Mm-hmm.
Those nunataks now there are mountains that you can see in front of you because the ice is gone. So those are some of the greatest witness you can observe when you travel there. Is like, oh, now there is this rock last year wasn't visible. Now I can see it clearly. And that's the same because it's important to connect both. It's the same in the Arctic and the Antarctic. You can see changes in the two polar regions very, 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 very easily. Those changes are noticeable, not even on the human life. It's just in a scale of 2 years, 3 years I've been there. I can already see changes. In the expedition industry, so tourism, let's just call it like this, there is a big movement now to become more and more sustainable, of course. The aim, I think those big companies, they understand that having the green etiquette is very important. So they all have their way to make it sustainable. There are some ships out there that are running on hydrogen for part of the time, not always. But most of the ships, they run on diesel generator, but they have extremely efficient engines. Diesel engines are in the maritime industry are old, like they are very the how can I say the engineering is very old, and what I mean by that is that we know a lot of things about engineering diesel engines for the maritime industry, but we come up now with a very good and efficient diesel engines, and the chimneys that used to smoke black smoke, that's gone. And now you have a lot of filters in those chimneys that are reducing the bad noxious gases in the atmosphere. So there is less of an impact from diesel generator nowadays. But then yes, you have those hydrogen engines that are coming up, and you have also other companies a bit smaller. Now I was talking more about the big companies. The smaller companies, they are sustainable in another way. They are trying to be using non-plastic on board, so there's absolutely no plastic on board. They are using eco-friendly detergent, simple things like this, but they are trying to make it as sustainable as it can be.
But is there still like landfills there? Like how do they dispose the trash? Like even the scientific station, how do they?
Everything is put. So for the research station, all the trash goes into the containers, and the containers are brought back. For the expedition industry, all the trash comes with the ship, and once we are at port in Argentina or wherever the ship goes in a developed country, the trash is being put on into the processing area. So there are same containers, and the containers are being taken away for processing the trash. And I know for having followed the trash that usually the expedition industry in particular, they are very serious about how the trash are being treated. And that's also part of the green etiquette they want to have. And this is one of the things you can act on. So it's and it's good that they know that they should do that.
And going back to challenging conditions that scientists experience, do you have any stories to tell regarding your just time in Antarctica, maybe as just a polar guide?
Well, yeah, there are so many beautiful things happening in Antarctica. But yeah, mostly as a guide. So the job of a guide in Antarctica is to introduce the beautiful Antarctica to people visiting it. But at the end of the day, it always comes back down to bringing everybody out and everybody back in on the ship.
Yeah.
And sometimes in Antarctica, you realize that things can go the wrong way, not as you have planned, and usually it never goes as you planned. I have this specific example of one time when we were in a place called Horn Harbor, which is again in the peninsula of Antarctica. And it started off as a snowy day, so cloud cover, a lot of snow falling down, but we decided to go on shore anyway. So we take our Zodiacs and we bring all our guests on board, on shore, sorry. And there they have their activities, so the little hike up the Horn pass, and then back down. And when you go on top, you have a beautiful view, and you also have chinstrap penguins. So you can contemplate the beauty of Antarctica with chinstrap penguins in the picture as well. So it's quite a unique place and one of my favorite. But as usually the operation lasts for 4 hours, so that everybody can enjoy the area. And in 4 hours in Antarctica, a lot of things can go wrong. And what happened is that we had a bunch of ice. But when we came in, the ice was all spread out in the bay. But as we were doing the operation, the wind started to blow, and all the ice came towards the landing site where we were, and all that ice blocked us completely from exiting the landing site. So there was us here on the Horn Harbor. There was the ship on the other hand, and in the middle you had a lot of ice, and it's called at this time of year was brush ice. So it's ice coming down from glacier, and that
is it like
that ice
just
just
wind, or is it like just icy rain or something like that?
no, it's all with the wind and the currents, the ocean currents, just blown everybody against everything against us. So we had a large patch of brush ice between us and the ship, and of course the brush ice is variable sizes of ice pieces from glacier. So you have tiny pieces of ice, but you also have tiny bergs, tiny icebergs, and you even have icebergs. So and it's quite scary because everything happened in like 15 minutes. The wind started to blow and everything came here, and we were like, oh, we are completely stuck. And so we had to drive everybody back on the ship because you cannot really stay out in Antarctica for too long. It's getting cold, so we had to keep everybody warm. Thankfully in the expedition industry we are it's very important to bring with us something called stranding bags. So we have stranding bags in case we get stranded. And in that case, we got stranded. So we could keep people warm by just using what was available in the stranding bags. But it took us a good 3 hours to just drive people from the shore back to the ship by navigating with the small Zodiac. So I don't know if you know what a Zodiac is. It's an inflated boat, a rubber boat with an outboard engine that is designed to take people in to enjoy scenery. So it's an open boat, inflated. And we have to drive this through this very large pack of ice, and it took us 3 hours to bring everybody back, and this was quite the mission, and the engines were suffering a lot. The rubber boats were also suffering a lot, and at the end of the day, we brought everybody back, but we lost about 5 to 6 propellers. So the propellers is what propels the boat, and usually a good season is you don't break a propeller. One propeller is like $3,000, but we at that specific day, we broke six of them. But thankfully, nobody was mad at us. Everybody was just happy that we brought everybody back, and this is what Antarctica can offer. It's very unpredictable. The weather patterns there are really unpredictable and can change like this.
Thank you, Julian. This is all for now. Don't miss out our in-depth conversation with Julian about Antarctica, which we'll be posting later on our LinkedIn page. See you in 2025.